Welcome back to the Flex Diet Podcast. I'm your host, Dr. Mike T. Nelson. On this podcast, we talk about all things to increase performance, more muscle, better body composition, and even some longevity stuff, all without destroying your health within a flexible framework. Today on the podcast, we've got PhD candidate and soon to be actual PhD Nathan Serrano, and we're talking about a new review study that he published in the American Journal of Physiology, Endocrinology, and Metabolism, entitled Muscle Fiber Phenotype, a culprit of abnormal metabolism and function in skeletal muscle of humans with obesity. So in translation, we're talking about looking at the muscle fibers themselves. What type of fibers are they? Are they slow twitch or fast twitch? And how does this relate to metabolism, use of fat, use of carbohydrates in people with obesity, and how is that different? And what I find interesting about this conversation is we learned some cool stuff, that if you have a high amount of fat next to the muscle, or what's called intramuscular triglycerides, if you are not moving around a lot, then this can be an issue. Ironically, if you are an athlete, that might be completely normal. And also that the fat stored next to the muscle in people who are untrained actually messes up carbohydrate metabolism and insulin signaling. So a lot of times we think that it's just more carbohydrates are bad, and it actually has to do with the flux rate of how much your body is using the fat that's stored next to the fibers themselves. And then we talk a little bit about some cool research he's got coming out looking at muscle protein synthesis, so how well you can take amino acids and add them to muscle tissue. He did a study looking at this, comparing them overnight fasted and fasted after, comparing it to an obese population versus a healthy population, and a whole lot more. Those are a super interesting conversation. We do get a little bit nerdy and down in the weeds, which is always fun. And if you enjoy this and want more nerdy goodness, you can check out my newsletter. And the best way to get that is via the Flex 4. So go to MikeTNelson.com/FLEX, the number 4, and that will subscribe you to the daily newsletter. And you'll get the exclusive content from this interview and past interviews about 4 questions that are not included on the podcast. So in this one, I asked Nathan, what would be the top 4 things if someone is currently not training? What would be his recommendation for the top 4 things they should do to improve their body composition and health? So you can get that at the Flex 4. So go to MikeTNelson.com/FLEX, the number 4. We'll have a link down below. If you're already on the newsletter, then you will get it sent to your email automatically once this podcast is out, and you'll be able to listen to all the other Flex 4 questions exclusively. Also brought to you by Tecton Ketones. If you're looking for a tasty ketone beverage, check them out. They actually taste really good. Each one has 10 grams of a ketone ester included in it, and we'll put a link below. I am a scientific advisor to them and an ambassador, so full disclosure on that. So enjoy this podcast with Nathan Serrano. Welcome to the podcast, Nathan. I appreciate your time.
Yeah, thanks for having me.
Yeah, and we'll just jump right into it. You published a cool new study that I saw that I think Andy Galpin retweeted, and I was like, oh, that's pretty cool. So I contacted you, and I'm like, hey, you want to be on the podcast and talk about it? And you're like, yeah. So here we are, and tell us a little bit about it and all the background and the cool stuff.
Absolutely. Yeah. Again, thanks for having me. I really appreciate the opportunity to come on and chat about this research. Like you said, yeah, Dr. Andy Galpin tweeted about this a while back and got a little bit of traction with a few people that follow him. So
nice.
Thanks to him.
He's got followers now, so.
Exactly. Yeah.
I give Andy shit all the time. I've known Andy for years, so he's awesome.
Yeah. So I guess a little bit of background
on
myself. I'm in my final year of my PhD. I'm currently at Arizona State University. I did my master's degree with Dr. Andy Galpin at Cal State University of Fullerton. And then before that, I was at Boise State University for my undergrad.
Oh, okay.
So both my undergrad and my master's degrees are both in exercise science. And then my PhD that started out as being in exercise and nutritional sciences. Long story short, for the sake of this podcast, I just transferred over to the biology program. My advisor ended up having to leave, so I just went with another advisor and now I'm in the biology program. Still studying the same stuff, still looking at muscle physiology, human physiology, stuff like that.
And
And
who's your
so
advisor currently?
his name is Christos Katsanos. He's done
Okay.
a lot of work in
No.
muscle protein synthesis.
Oh, cool.
So yeah, so he was one of the few initial investigators to look or start using stable isotope leucine as a tracer for studying muscle protein synthesis.
Nice.
Yeah, and so I've been here for 4 years. We've been looking at human obesity and muscle protein synthesis, and then I brought my expertise with muscle fibers, and we started diving into what regulates muscle myosin heavy chains. If your audience at all
Explain a
follows
myosin heavy chain if people are
Yeah, I was
like,
gonna say
hey, what the hell is that?
exactly. So if your audience is at all up to date with Dr. Andy Galpin's work, I know he talks about muscle fibers quite a bit, but
Mm-hmm.
I'll give you the background.
Yeah.
So most people understand that we have fast and slow twitch muscle, and so within those two, we have the main contracting proteins, myosin heavy chain and actin, that most people hear about, that are going to be the main proteins that are involved with muscle contraction. And so these myosin heavy chains are the ones that we look at because those are going to dictate how quickly or how powerful the muscle is able to contract. And so we have slow type muscle fibers that will have one myosin heavy chain called 1. And then the fast fiber types have what's called 2A myosin heavy chain and 2X myosin heavy chains. And those two, both of those are quite a bit faster in their contracting velocities. And so we call this fast switch, with the 2X being like extremely fast and very rarely found in humans.
Yeah. You actually see those in a detrained population. Is that correct?
That is correct. So we do see that in detrained or sedentary populations. We also see those in some diseased populations, like renal failure populations. We also will see that in, there's been studies that simulated loading to simulate space travel, right? And 2X and tends to pop up a little bit more in those populations as well.
Did they, as a sidetrack, did they know why that is? Because that always seems very counterintuitive. It's, hey, let's put you on bed rest or toss you into outer space with no
Mm.
gravity or have you not move around much. But wait a minute, you get like this super fast muscle fiber type.
I I don't have a great answer because that's something that I'm trying to answer myself.
Ah, cool.
And
Okay.
I haven't really come to much concrete evidence for why that is, other than any type of loading in the muscle is pretty good about sensing tension, mechanical. And so any level of mechanical tension that's being sensed almost immediately shuts off this 2X gene.
Hmm.
And so I think the thought would be during these periods of unloading, there's nothing to inhibit that 2X gene. And so it ends up being the protein that gets made more because of just sheer elevation of what's in the pool of the genes that are floating around. So
Yeah,
that's my guess, but I don't have data to back that up.
yeah. What do you think of my wacky idea that if the body is programmed for survival, maybe this 2X fiber type is like the last of the redundant systems. It's,
Right.
hey,
Yeah,
if
that's
you're gonna
also
unload us, we're gonna have this 2X
mhm.
that's gonna appear just to try to save us for doing a sprint for one last time or something.
Yeah, that's definitely a theory that's popped up in the literature as well. Thought to be our survival tactic of reserving some level of the fight or flight response,
Right.
right? So our muscles are still able to meet the demand of having to flee. And so that's a pretty common evolutionary biology type theory for why we have these 2X fibers lingering around in periods of inactivity.
It's also one of those
So
theories it's really hard to get to why. It's like we can show that this
yeah,
happens routinely, but trying to run an experiment to
mhm.
determine why Yeah, I haven't come up with anything on that.
Yeah, it's so tough. For one, you'd probably have to put people on bed rest, and it's hard to find people that would voluntarily be put on bed rest for periods of time like that.
Yeah,
You have to do all the omics probably to probe everything and then try and narrow it down after that. All of those are time consuming and pretty expensive um, to
yeah.
do.
And
So
even then, if you show that it happens, unless you find some weird omics pathway that you didn't know was there, which is entirely possible, you're
yeah,
left with, oh yeah, it's a thing.
yeah, exactly. That's kind of where I'm landing at the current moment. So this happens. I can't really pinpoint why, but I know this happens.
Yeah, cool. Well, I
But yeah,
detracted you from your explanation there. We were talking about heavy chains, and then I distracted you.
right. Yeah, no worries. So yeah, so myosin heavy chains are the main contracting proteins that dictate our muscle performance. And so slow twitch muscle fibers are often associated with endurance training, or fast fiber types are more often associated with strength training, specifically the 2A fiber types. And so if you are training for marathon or kind of your recreational distance runner, you're going to have a lot more of these slow fibers. They tend to be more abundant in things like mitochondria that help give us energy for these workouts. Blood supply, there's more capillaries around these muscle tissues, and so they're more equipped to sustain physical activity for long periods of time. And then the 2A muscle fibers can have similar amounts of mitochondria around, they can have similar amounts of blood supply, but it's still less than type 1s. The 2X ones are the ones that really diverge and are far less equipped with things like mitochondria and blood supply, enzymes that are good for synthesizing our energy, ATP. And so that's why 2X is generally thought of as being a little more deleterious of a fiber type. Not as many beneficial outcomes that are associated with those, whereas 2A, the type 1s are. And so in my current research, we do a lot more kind of clinical work looking at obesity, type 2 diabetes. And so we look at mostly myosin heavy chain 1 and 2A for those reasons. Is that good enough background?
Yeah, and I think for listeners also, type 1 fibers tend to be very small in diameter because they're relying on primarily the aerobic process of oxygen to
Hmm.
diffuse across, where 2A, you can have more anaerobic metabolism, if I'm
Right,
just using colloquial terms here. And you can have
right.
a fiber that's a little bit bigger because you don't have to have oxygen diffuse all the
Mhm.
way into it.
Yeah, and actually, we've seen individuals that have pretty large type 1s, and you can see
Hmm.
this in bodybuilding. Theory behind that is they're doing higher rep ranges, and so they're still having to be equipped with robust mitochondria, robust blood supply, robust enzymes that are going to sustain them through those really grueling weight training sessions. But they're also going to have massive 2A fibers. And so, relatively speaking, the 2As are still going to be bigger than the type 1s in that scenario. But
And
that's very, very true. Type 1s tend to be a little bit smaller.
yeah, and that matches a conversation I had, God, several years ago now with Dr. Brad Schoenfeld, where he
Hmm.
was hypothesizing that high rep stuff, and Nick Bird's done some stuff with 30% to 1 RM
Hmm.
and some other interesting stuff, blood flow restriction too, that his hypothesis at the time was that doing this higher rep work, you could see significant hypertrophy in type 1 fibers. And
Hmm.
I think there's been some data that's shown that to be true, which kind of matches what you were talking about, correct?
Right, and actually, I got those from Brad Jones's
Ah,
work.
cool.
So
Yeah.
yeah, yeah. So definitely credit to him and the stuff he's put out in the last what 15 years or whatever.
Yeah, tons of great
Um,
stuff.
yeah, I totally lost my train of thought, but yeah, so
So we can have some hypertrophy of type
you
1s,
can
and but
have
it's still mainly
hypertrophy of
type
type
2.
1s. It's mainly type 2. 2X is said to be like the larger one. Like basically, it stepwise goes up with the fiber types. So myosin heavy chain 1 tends to be the smallest, 2A, and then 2X tends to be larger. That's not always the case either. If you look at some of the literature, there's a lot of great examples of 2X fibers being the smaller one.
Hmm.
Not sure why this is the case, but it can go basically. All of these things are on a continuum, right? So myosin heavy chain, these fiber types, they can exist in multiple forms, and their sizes are going to vary as well. So to say one fiber type is really one size, or uh, I think it's maybe a oversimplification of what our muscle can actually do. But along those lines, I think it's important to also mention with this background of fiber types that we don't just have those three categories. We do have these kind of in-between fibers we call hybrids that are going to have both slow type and fast type properties. And so these hybrids will often, you'll see the type 1, 2A or 2A, 2X. There's other types as well. There's 1, 2A, 2X. You see all three myosin heavy chain isoforms in them, or 1, 2X as well. And so all of these things are going to exist in this continuum. So I guess take some of these fiber type associations with a grain of salt, because at the end of the day, our muscle is highly plastic. It's very highly variable as well. And I haven't seen anything that really solidly states that these muscle fiber types are set in stone. And so I think that's great maybe for your audience who exercises a lot. Your fiber type's going to change. How quickly is that going to happen? Not very fast. It's going to coincide with how quickly we turn over our muscle tissue, which is pretty slow. So talking about muscle protein synthesis, as we turn over our proteins or break down our muscle tissue and then replace it with new proteins, that's happening maybe at 0.2% per hour. So I think, is it like 3% a day or something like that?
Yeah.
So
But
over the course of a couple months, you'll see your muscle tissue being fully overturned. But
I think it's
that,
like 30 to 90 days now, isn't it? I think Van
yeah,
Loon was
somewhere
talking
around
about
that.
that with
Yeah,
some of the studies that he did with some stable isotopes that I can't
right.
remember exactly what it is, but it's not super short, but I think it's a lot shorter than what most people would realize, because I think most people are thinking of the body as this sort of semi static thing. Because you look at your right bicep and you're like, it still looks like my right bicep. Like, even if you're trying to
Right.
make it bigger, it takes a long time, but the amount of turnover that's going on in the background, in my
Mhm.
opinion, is crazy high. It's higher than what I would think, I guess.
Yeah, I say it happens slowly, mostly to remind people that progress happens pretty slow with exercise.
Oh, definitely.
Um, but it is, I would say, surprisingly quick. It turns over in, between 2 to 3 months, something like that,
Yeah, yeah.
which is pretty quick. I guess in the grand scheme of things, it's fairly quick. And so muscle tissue is one of the more fascinating tissues to me, and obviously I'm biased, but it's because we're turning it over constantly. And so every few months, right, we have brand new muscle tissue as long as we're exercising, eating, all that stuff. And so I think that also highlights our ability to then change that muscle tissue as we're doing our whatever lifestyle changes, right? So if we're just starting on an exercise regime, then give it 2, 3 months, and you will see some progress, and give it another 2, 3 months, you'll see some more progress. So yeah, to me, it's fascinating how quickly that can turn things around if you are looking
Yeah.
at it that way.
Because to me, it's crazy to look at say, your right bicep and then go in 3 months, literally almost all that muscle tissue has been replaced.
Yeah,
That to me is still wild. And the fact that it looks the same, right? So you go down this rabbit hole of maybe spending too much time thinking about this, that with all the turnover rates, I think Van Loon did one study of looking at protein turnover rates in the brain were like 30 days or something crazy.
yep,
But yet changes to the systems is still relatively slow, right? If the maximal rate you could add muscle is maybe what, zero point 0.5 to 1 pound per month, somewhere in there, if you're a
yeah,
natural athlete, and that's probably on the high side.
right, yeah,
Bone turnover, like in terms of gaining bone, is very long. But yeah, it's always fascinating to me how the turnover rates are high, but yet we tend to look the same month in and month out, even if we're aggressively trying to add lean body mass.
yeah, yeah, yeah. It's interesting how just quickly it seems to happen, but how like how subtle the changes like visibly are. So I guess back to this review paper that we put
Yeah.
out, we're looking at muscle fiber types. That's been a huge interest of mine since I was working with Dr. Andy Galpin. And so going into my PhD work, we're looking at these protein synthetic rates, looking at myosin heavy chain, specifically within obesity, mainly because there seems to be a reduced rate of protein synthesis in individuals who have a higher BMI or higher body fat percent. And so the question obviously is, why is that happening? We don't fully understand why. We're still running clinical trials trying to figure it out. But one of the things that we did find that was interesting is that when you infuse amino acids, maybe not super interesting at this point, but when you infuse amino acids that are building blocks for proteins, these individuals, this population tends to basically close the gap on their protein synthetic rates. So if you compare obese individuals with lean individuals, obese individuals at rest are going to have a lower synthetic rate, but when you give them amino acids, they make up that gap. If you have them exercise, so now the question was, okay, well, when is this window that you need to give these amino acids to individuals? Is it pre-exercise? Is it post-exercise? Well, first, we got to see, is exercise giving them any amount of protein synthesis on its own? The answer is no. We
Really?
published a
So they
paper.
don't get a bump from exercise? Because for comparison, correct me if I'm wrong, but lean healthy individuals would get a bump for 24, 48, maybe 72 hours, depending upon the study, the group, etc.
Right, yeah. So the only thing I would say with that is the time points that we measured probably may not have measured far enough out. We measured at 4 hours.
No, that's pretty long
Um,
though.
it's pretty long, and we would have expected to see something there,
Yeah.
but we didn't see any increase in both groups. And so again, this is in kind of in a fast state, not kind of, this is in a fast state. So these are essentially what we drew it up to being as just having a lack of amino acid in kind of the pool to grab from, to recycle and start building these proteins. And so we didn't see a bump after exercise. What we're currently doing is now we're doing exercise and amino acids to see if that gap still is being closed or if it's an even more robust signal.
So just so I'm clear, so you had people come into the lab overnight, they were fasted, you do the
Hmm.
infusion, you had them do some exercise, and then they stayed fasted for up to 4 hours. And in
Right,
the obese group, you didn't see any change in muscle protein synthesis, correct?
right.
Got it.
Yeah, so we didn't see any increases compared to the lean as well. So the lean individuals also didn't show that increase. And so that tells us that there's a lack of nutrients there to actually stimulate or be able to carry out protein synthesis.
Oh, so the lean group
It's
didn't see a
it's
bump
like
either.
yeah, so it's likely that protein breakdown may have also just been exceeding the synthetic rate. We didn't measure breakdown, but again, this is an acute study, so tough to measure everything that would show whether or not overall protein is being built.
Because this
But
is the working theory in a lean, healthy individual that you would be able to take some amino acids out from the amino acid pool that's floating around in the blood and kind of
right,
redistribute them.
and so that is the thought, but
Theories don't always play
yeah,
out in
theories don't always
in
play out in it,
experiments.
but right, but also again, this is more of an acute. It may have just been that the stable isotope wasn't being infused for a long enough period of time to catch those subtleties,
Sure.
um, which is obviously a downfall to using stable isotopes. You can use something like doubly labeled water, where you can track it for over several days and see that subtle change a little easier. But with that said, we haven't seen any increases in protein synthesis in these individuals. And so now our current clinical trial is looking at amino acid infusion and exercise. And so what we had them do, they came into the lab, fasted, we gave them the stable isotopes so we can track. Then they did a bout of exercise, and then immediately following that exercise, we gave them the amino acids, and we're going to be measuring at
Was that amino
uh,
acid infusion or was it like a protein
amino
shake
acid
orally or
infusion. It's
okay.
an infusion, yeah, to make it easier on them.
Sure.
They don't have to, although I'm sure they would be pretty excited to be able to consume something at that point because they're fasted for close to 14, 15 hours. But that data hopefully will be out in the next year or two. We'll see what happens with that one. So with that in mind, we wanted to write this review paper that was looking at what's the association of myosin heavy chain to really set the stage for all these associations of myosin heavy chain and muscle fiber types and different outcomes or characteristics that we tend to associate fiber types with. So things like lipid accumulation, protein synthesis. And so all of these things set the stage for muscle fiber types as being the culprit of driving metabolism in a way. And so what we say in the paper is basically that these muscle fiber types, they're making up X volume of your muscle. So if we use, say, your thigh muscle as an example, and typically when we do these studies, we'll give a percentage of myosin heavy chain content, muscle fiber content, right? So you have 50% type 1, other 50% type 2A for simplicity. Well, then that would theoretically mean that 50% of the volume of your thigh muscle is type 1 and 50% of the volume of your thigh muscle is type 2A. That could be the case when we're looking at muscle fiber types with single fibers and you're tweezing single muscle fibers under a microscope and then you're measuring myosin heavy chain. You're not exactly testing for muscle fiber size. You miss that. So we don't always associate single muscle fiber distributions with the muscle volume. But what we can say is the more of these fibers you have, the more likely it is that they're encompassing more volume of your thigh muscle. And so because of that larger volume of that specific muscle fiber type, you're going to have more characteristics of that fiber type. So for instance, type 1, you're going to have, if you have a higher percentage of type 1s, that's more volume taken up within your muscles. That's going to be characterized as all of those things that I mentioned earlier, mitochondria, capillaries, enzymes, all those things. And so that's going to impact your metabolism. Where the paper starts to make a little bit more of a pointed argument is how that impacts obesity, right? And so there's a lot of research out there that shows that obese individuals tend to have less type 1, which means that there would have to be an increase in these fat fibers. We're looking at just content distributions. Then that means 2A would go up, 2X would go up. We already mentioned that 2X is pretty deleterious to a lot of outcomes. And so this review paper is basically setting the stage for that, for us to then hopefully soon, at the end of my dissertation, I should have more data to show with that, what's happening on the side of 2X. And so we would hypothesize that because type 1 is going down and sedentariness and obese individuals being more likely to be more sedentary, it's not always the case, but they tend to be less active, then we would expect these 2X fibers or fat fibers overall to increase. Along with that comes with things like increased accumulation of fat within your muscle tissue. We know that to be deleterious to muscle quality. I use the analogy of marbling, right? So for those of us who eat meat still, marbling looks nice on the plate, not too great for muscle quality and our muscle performance. So the more fat you have within your muscle, the more damage you're allowing to happen because you're having to use all those fats. Those fats have signals that are sent out to the body, usually in the form of inflammation, things of that sort. And so things get interfered with that wouldn't be more normal. Things like insulin signaling, right? So insulin is needed to bring in glucose from your bloodstream from your meals. It's also going to transport some fats as well around the body as they're being used. But if you're not using those fuel sources, they're just sitting there and being stored. And so we get increased body fat percent. And so,
which I think is an interesting point because I wouldn't say a lot of people, but a lot of people on the old internet would say that, oh, bro, it's just carbohydrates. You eat too many carbohydrates, and
yeah,
that's messing with your insulin signaling. But when you look at
yeah, right.
the literature, at least in an untrained population, it's exactly what you said. It's the intramuscular triglycerides get bigger. And correct me if I'm wrong, but there's no flux through them. It's just like a storage depot for fat, where some high level endurance athletes, you still have some intramuscular triglycerides, but they don't seem to have as negative effect because you're literally storing some fat there, but then you're oxidizing or you're burning it on the other end. So you have this turnover and
Exactly.
this flux of fat kind of going through it, and that doesn't
Exactly.
appear to be as detrimental.
Exactly. Yeah, there's actually some really interesting literature. It seems paradoxical at first, right?
Right.
Kind of to your point, endurance athletes will have more of this intramuscular fat, but they are cycling through it pretty frequently because they're obviously working really hard. They're doing their training. Either that, or if you're doing a marathon, you're burning through all of the fuel sources that you have stored in your body,
Yeah.
and so your muscle's going to draw from that. But if you're not active, you're sitting on the couch and not doing a whole lot of activity, then those depots, the storage depots of fat and sugars get filled up pretty quickly, and then it goes elsewhere. It goes elsewhere in the form of basically fat around your organs or visceral fat. And we know that to be extremely deleterious to your health. And so that's another thing to consider when you're talking about muscle performance, fat accumulation, stuff like that, and even diabetes. These are mainly, and this is probably going to be not too popular with the internet, but
Ooh, that sounds good then.
right, yeah. But these things are, it's just a lack of activity.
Hmm.
If you are using your muscle and you're burning through those fuel sources, they're not going to be stored. Or on the other side of it, if you don't bring in excess of those fuels, then they're not going to be stored. And it sounds maybe oversimplified, but it really is that simple. If you're using those fuel sources, they're not going to be stored. Where it starts to become more complicated, and probably a little more of a discussion maybe beyond this podcast, is the behavior behind it. The behavior, I think, is a very real barrier for a lot of people. And so, whether that's socioeconomic or otherwise, then it starts to muddy the water a bit and it's a little more complicated to get that. But at the end of the day, the equation is very straightforward. We've known this for a long time. It's calories in versus calories out.
Yeah, and it's crazy to me how if you're in a massive caloric surplus, how much that will start to mess things up, and you get an extremely protective effect from exercise as long as you can keep scaling exercise. Like there's some
Mm-hmm.
studies in sumo wrestlers and I think some NFL linemen that show metabolically they're actually pretty good. But the
Mm-hmm.
second they stop training and they stop having that high background of exercise,
Mm-hmm.
they go to shit real fast because they have this
That's
huge caloric excess and they don't have this
mm-hmm.
massive exercise buffer. And on the
Yeah.
flip side, a caloric deficit makes up for a lot of other weird ills too, because you just literally don't have as many things that you need to stuff somewhere else that they shouldn't go.
Yeah, you're not demanding a bunch of different shuttling things that either are helpful or not helpful. If you're just reducing the stress on the system by doing caloric restriction to a point, obviously.
Yeah, you don't want to, hey, I'm going to drop to 500 calories a day or fast for
Yeah,
4 weeks or
yeah,
crazy stuff.
yeah, exactly. But yeah, that's more or less the kind of broad idea behind this paper is that like all of these things can in some way be linked back to muscle fiber types, and muscle fiber types are probably impacting metabolism to a greater level than what they've previously been thought to. Oftentimes, people have treated muscle as the just strictly mechanical tissue,
Hmm.
and we know that's not the case anymore. We know that there are signals that are being thrown around the body that are talking to other tissues, other organs. We call these myokines. And so those things are communicating with the rest of the body. Hey, we need this, bring it over here. Hey, we need that. We don't need this, you can have that. So things like lactate, right? Lactate gets shuttled around the whole body during exercise. And one of the things I always talk to undergrads about is do some strenuous exercise where you get that burn, where you're getting lactate buildup, and then work another muscle group out and see how long that can actually be sustained. Like you'll feel you can do like a massive, not massive, but you can do a substantially longer bout of exercise after loading your body with some lactate because you're using it as a fuel.
So the theory there is if I want to go out and do 30-second wind gates on the rower for repeats, and then I'm going to go do some bicep curls.
Yeah,
Right? The theory is that because the bicep curls weren't really worked all that much, but I did a
exactly.
bunch of Wingate stuff, so I'm producing a ton of lactate, lactic acid, which gets to be lactate and
Hmm.
hydrogen ions. But
Right,
then because I'm doing a muscle that wasn't necessarily worked as much, I've got high levels of lactate floating around, which is a high energy fuel to actually do more work on my bicep curls, for example. Is that correct?
right. Exactly, yeah. And so I talk to undergrads about things like this all the time. So things like lactate, things like
So you're saying lactate's not evil.
exactly. Lactate definitely not evil, and it's definitely not sitting in your muscles for more than a couple hours.
Bro, this is not
So
what's making my muscles sore.
exactly,
Ah,
exactly. Gears. I'm a uh, teaching assistant for anatomy and physiology, and every time we go over muscle physiology, I make a huge point. Lactate has nothing to do with your fatigue. It's hydrogen ions, it's a lack of fuel, it's pH maybe,
yeah.
or it's calcium and potassium kind of imbalances, right? So those things are going to contribute to your fatigue more so than lactate ever was thought to.
What are your thoughts about lactate as a supplement?
I don't know. I haven't really looked at or looked into that very much, nor have I really heard of it being a supplement very much. I don't know. If you have, I would love to hear about that.
Yeah, this is one of my pet theories for like almost a
Okay.
decade now. And so for
Yeah.
the first like 6 years, I had NDAs with companies
Hmm.
and just trying to get them to buy. I would never, you're insane. This is a stupid
Hmm.
idea. And then about 4 or 5 years ago, I just gave up and I'm just like, hey, someone go do this, please. And
Yeah.
there's been a couple studies that have been done with mixed results. The lactate that George Brooks originally had with
Right.
Cytosport
That's
is off patent now,
okay.
my understanding. The amounts that have been used in most supplements, I think, are too small. Calcium lactate is off patent, so you can get that. I've played around with
Okay.
it a little bit, but I think the rate limiter, like with ketones or like at least beta hydroxybutyrate, is what are you attaching it to get it across the intestine?
Right.
And,
Yeah.
you're probably going to need a pretty hefty dose. And then the early ketones, if you only attach it to sodium, well, crap, now you've just loaded your gut with this huge amount of sodium, which can cause disaster pants and all sorts of
Diarrhea.
other
Yeah.
issues. I
Yeah.
may have experienced that with the early versions. But again, you could split it across different ions. If somebody patents
Right.
this, please at least include me. Thank you. But anyway, because in theory, the pKa
It
makes
should.
sense.
Yeah.
It
Yeah.
does appear to be when it's bound to an ion, it does appear to cross the gut. It does appear to show up in the blood. We can
Hmm.
easily measure it in the blood. And if you can get high levels of lactate without the pesky hydrogen ions, your brain loves lactate, your heart loves
Right.
lactate, your
Yep.
muscles, they want to use lactate because it's a high energy fuel that's already there. It's just
Right.
normally it's produced at the same time as these high levels of hydrogen ion that bugger everything up. So
Right.
anyway, that's my
Exactly.
little spiel.
Yeah. No, that actually reminds me that. So I know a couple of George Brooks's current PhD students, and they've talked about the studies that they've done with these lactate supplements. And yeah, that's the first thing that always comes out of everybody's mouth is, "How's your bowels?"
Yeah, yeah.
And
Yeah, and
so
I think
yeah,
his lab's done
aside from
some
that, yeah.
stuff with TBI and actually lactate infusions,
Hmm.
I believe, correct?
Yes, yeah. I think they recently published some of that work, and they're also looking at like postprandial lactate in the gut, something along those lines. But yeah,
Yeah. So anyway, if someone does develop that, let me know, or I don't know,
yeah,
send me a percentage, whatever. Because I'm just curious because just because, God, what was it? Peter Lemon said, just because it's logical doesn't mean it's physiological. So a lot
yeah.
of stuff that like we think works good on paper, like you could go down the list of, God, we've probably tested what every other Krebs cycle intermediate
Hmm.
from pyruvate to citrate to whatever, and most of them are a bust. Creatine
Right,
is the rare one that was beta alanine, maybe different mechanism, but all the other ones you could have this laundry list of, bro, this should work because of where it enters here, and you got more of
yeah,
this and that, and it didn't really pan out.
yeah. Yeah.
Very cool. And if you were to go out on a limb, if you are someone who is not very metabolically healthy, and we would hypothesize that maybe you have more intramuscular triglycerides that are gumming up the works in the muscle, would you be a fan then of an intervention of fasted cardio to try and target and increase the flux through those intramuscular triglycerides to try to combat that? Obviously, caloric deficit would be number one, but
hmm I, oh, what I'll say is on paper, it seems like that would, but what I would probably recommend more so than anything is doing exercise that depletes your muscle of the most glycogen as possible.
that was my next question. And why would
Do
you pick
lots.
that?
I would pick that because that sensitizes your muscle to insulin, so that protects you from becoming insulin resistant. And so the more often you can do that, you're gonna burn through those triglycerides. It's not a question of if, it's a question of when. And so if you consistently do glycogen depleting exercise, that you're probably um, going to be on the same track. I don't know for sure if or how well doing fasted cardio burns through triglycerides off the top of my head, but you're going to get a similar effect. Is it now? This is where it gets a little bit muddy. Is glycogen depleting exercise is pretty tough.
That was my next question. What are you going hardcore where you're like under 50 grams of carbs a day and doing exhaustion stuff? Or are you doing like the exhaustive work, like the sleep low studies where you just get a little bit of protein and you come back the next day fasted and you hammer the same thing again?
You can do something like that, or you can do long duration exercise, goes through a good amount of, so I'm not talking about full depletion, but you've got to stimulate some level of glycogen repletion at the end of your exercise. And so if you're able to stimulate the replenishment of glycogen into your muscle tissue, you're still stimulating insulin. And then couple that with being in the caloric deficit or at least within maintenance, and not excess, then you're going to be on the right track.
So if you were to
And
program exercise to do that, what would you program just so people have an idea? And I know we're
sure.
getting pretty hypothetical here, but
So I'm not a huge proponent of any one type of exercise or any one exercise is the best. And I tend to try and program individuals to do physical activity that they're able to sustain as because they enjoy it, not because
totally.
they think it's good for them or whatever, because that tends to just create a bad habit of despising the activity that you're doing and then it just doesn't work out long term.
Your
So
body's not going to want to do a lot of stuff you hate.
exactly. And so if I can find some type of long duration, sustainable exercise that they can do twice a week and couple that with maybe some HIIT training once a week and then some strength training. I think I don't want to fall back on all of Dr. Andy Galpin's works or all of his words, but he does say something along those lines where you should do long duration exercise 1 or 2 times a week, HIIT exercise once or twice a week, and then strength training 3, 4 times a week. Um, do stuff that increases your heart rate as often as possible. Um, and I think you'll see that things start to clear up pretty quickly. And so that's my general recommendation. Obviously, we're getting into kind of more details. You can look at length of intervals. Interval training is by definition more like 1 to 1, and it's usually 1 minute to 1 minute, or anything beyond that. A lot of the HIIT research, at least, starts there. You can look at sit or sprint training, right? Sprint interval training. That's more 1 to 4 ratio for rest to work, or sorry, work to rest, where it's really short periods of basically max out exercise. So if you're doing sprints on a track, probably don't want to do that on treadmill. That can be pretty hazardous.
Yeah,
You
I
can do
don't
it on, say, a
recommend that.
bike, maybe a bike.
Bike works
Um,
good. Rower
bike
works
works well,
good.
exactly, or run on a track. and you can do it that way as well. That works pretty good. If you do enough of those, you'll get pretty depleted. You'll feel it. And so we follow those, I think, modalities, and you can um, start to see some progress, I think, pretty quickly.
And the cardio, the longer stuff, are you thinking like zone 2 or kind of more cardiac
Mm,
development, zone 3-ish, or does it depend on the fitness level of the person?
I would say it depends on the fitness level of the person. Going by most people will go by the zone two. People like Peter Attia and swear by zone two being the best target for a lot of people. And I on many levels agree with it, but I also do this idea is the what do they call it? Gears, which is I believe Dr. Andy Galpin and
Yeah,
Brian
from Brian
McKenzie.
McKenzie. It's like
Exactly. Yeah.
nasal breathing, adjusting by
Hmm.
nasal in, nasal out, nasal in, breath
Yeah.
out, mouth in,
Yep.
mouth out.
Exactly. So I like
Yeah.
the gear system as well, and I think I don't think someone who is not well accustomed to exercise is going to be able to do that very well. They're going to stay probably in gear one for a while until they can get used to that style of breathing or really just learning what that even means. And so zone two for that case would work really well. Um, but somewhere in the realm of probably zone two, zone three, or gear two, being able to nasal inhale pretty consistently, I think it is pretty powerful, and I think that's a good spot to be in for these long duration style exercises. Um, yeah,
Cool. Yeah, my bias is I think zone 2 can definitely be beneficial if someone's not really trained at all.
right.
Psychology aside, right? That's a whole nother
Hmm.
issue of doing 40 to 60-minute bouts 2 to 3 times a week is probably what you need. I only tend to have people do it for 6 to 8 weeks. Again,
Hmm.
if you're an extreme high-end cyclist where you're training 18 friggin' hours a week or something, then yeah, you're gonna probably have more zone 2. But those
Right.
people are all batshit crazy, and if you tell them not to do anything, they're gonna go ride a bike anyway. So I
Yeah,
have this
yeah,
theory
yeah,
that telling them to do zone 2 is just pure recovery work for them to
yeah,
stop them
yeah,
from doing
exactly.
high intensity stuff. But then after that, I'm more a fan of what I would just say is the cardiac development. It's like in Brian
Hmm.
McKenzie's system, that would either be very fast nasal in, nasal out, or
Hmm.
nasal in, mouth out. Because I just think you get better cardiac adaptations from there after a period of time. But again, that's just
Absolutely.
my own bias.
No, the research is starting to finally catch up with a lot of these breathing protocols or
Hmm.
breathing kind of frameworks around exercise. And I think we'll start to see a lot of that style of exercise being connected with your rhythm of breathing, where you're breathing from. So I think there's a lot of power in nasal in, nasal out, and nasal in, mouth out. And I try to do that as often as I can when I am doing these longer duration exercises. I'll try to maintain nasal in, nasal out as long as I can until I have to take a few mouth breaths, and then I'll go back to nasal in, nasal out. And so I haven't programmed for people in that style just because I feel like it's tough to get a gauge of what people are ready for those types of things, at least in my case. If I'm not doing it in person with them, then it's tougher for me to make those subtle changes and like, oh, it's okay. Like you can do some mouth breathing if you don't
Yeah.
force yourself to pass out because you are only on nasal in, nasal out. Do
Yeah.
a couple mouth breaths, catch your breath, make sure you're not going to pass out, and then keep going. So there are certain kind of subtle coaching cues that I would fall on that makes it tough for those, at least for me, to really program those adequately. But I think in a general sense, I try and stay towards just do something that you can sustain for whatever time it is that you plan to be out. I'll give you an example. I have a client that I've been working with for close to 10 years now.
Oh, wow.
She's
Nice.
out in Alaska. She's a DO out in Alaska, and we've been working together for quite some time. I've given her kind of I've thrown everything at her. She's been a little bit of my guinea pig at times, but I don't ever prescribe her a very specific type of long duration. It's always just pick something this weekend, go out for a hike, go for a bike ride, or just go for a couple miles run.
Yeah.
Any anything is better than nothing. It doesn't have to be a whole lot with metabolic exercise. A little goes a long way, and a lot doesn't go that much further. So I'm like, just do 1 or 2 days a week and you're solid. So I don't tend to be a huge stickler on you have to do this distance or whatever. I guess thinking more from a general population perspective, I think more people will get a lot more bang for their buck of just sticking to those 2 days a week, doing something long and sustained, and generally sticking to some type of resistance training the rest of the days. And so that's how I approach most of my coaching.
Yeah, very cool. I had a proposal. I had an NDA, but it's soon expired. Is There's a company that had I won't say the name, but it was basically a device where you could adjust concentric and eccentric contractions separately. So you could have different amounts of loads for them. You could have high concentric and no eccentric, or you could have a
Hmm.
high eccentric, no concentric.
Okay.
It's a motorized system. And so they
Okay.
were looking at it for treating people who are borderline diabetic. And so I wrote up a little protocol, psychology aside, where I just beat the crap out of people with concentric only work, like just
Yeah.
hammered the living shit out of them. And my
Yeah.
thought being, I want as much muscle contraction as possible, but I
Yep.
don't want to make them ridiculously sore that they
Yep.
don't show up the next day
Yeah.
again.
Yeah.
And with the
Absolutely.
machine, you could do that.
Yeah.
Any thoughts on that in terms of
No, I love it.
insulin sensitivity? I know it's very theoretical.
Yeah, that would definitely be pretty theoretical, but I love the idea behind it. I think it seems like it would, both in practice and on paper, do a great deal for insulin sensitivity because you are, again, like you said, just hammering the muscle away without causing too much damage that they would be so sore that they don't want to continue. And that's the trouble with a lot of these kind of resistance training
Right.
studies is like you get these individuals starting to do resistance training and then they drop out of the study because they're too sore to continue or they think this is bad for them because they're so sore. Um, so yeah, that's a fantastic idea. I really like the approach of doing most like basically concentric only. When I was doing personal training in person, we would definitely have a lot of try to do like a decent amount of days of like concentric only movements just to keep people coming in.
Mm,
Not only that, it's pretty good to get people concentrically really strong without hammering on the tissue so much that they're getting some sort of overuse injury. Because some of these are athletes, right? So some of the athletes you don't want to hammer their joints with so much concentric, eccentric that their tendons are starting to get a little overstressed or overused. And so I think concentric only is a great way to get around that.
yeah, I used to do that a fair amount when I trained more people here at my house. I didn't tell them this, but I basically did what I call like concentric circuits. So
Hmm.
we would do like car push, sled drag, reverse sled drag,
Yeah.
sledgehammer on a tire,
Yep.
rower, maybe kettlebell swings if they're really experienced, but that could add
Yeah.
some high eccentric to it. So usually I would drop that, but they would just repeat that
Cycle through.
circuit.
That sounds
It's
exactly like what we used to do
it's
when I was.
friggin' hard,
Yeah. It's
and
so hard.
they're not high skill movements, so when you're
Yeah.
fatigued, like you don't have to worry too much.
Yep.
They
Exactly.
all the clients like loved it, and you could beat the crap out of them. And amazingly,
They
they
love
wake up
it.
the next day and they're like, "Hey man, I feel
I
pretty good." And I was like, "Oh,
yeah.
sweet."
Yeah. Yeah. No, that's definitely the style of training that I would program a lot for general population just to make sure that their soreness was at least kept to a pretty low level. And they all seemed to love it because it was like super grueling
Yeah,
exercise and they'd be pouring with sweat and oh my God, that was like one of the best workouts of my life. And then they
yeah,
come in the next day and look ready for more. I was like, okay, let's do it again.
yeah, yeah.
Yeah.
Cool, man. Awesome. Well, thank you so much for all your work. I really appreciate it. Thank
Yeah.
you for publishing the review study there. I'm super excited to hear more about your thesis once you can share all the information there. And
Yeah, definitely.
yeah, are you going to be at ISSN next week of this recording or not? I know you're busy in the lab all the
No.
time. No.
Yes, definitely not. I don't typically go to ISSN. I usually go to ACSM or the American Physiological Society.
Oh, cool. Yeah.
So I typically go to those. I'll probably start going to NSCA again soon.
Yeah.
But yeah, those are the main ones that I usually go to. And then I'm trying to actually finish in July, so it's
Oh,
like
awesome. You're getting very close. Super close.
extremely close. So it's definitely been in the trenches for a while now. So looking forward to getting out.
Yeah, I can honestly say my PhD was by far the hardest thing I ever did. It was
Yeah,
not only difficult, it's difficult day in and day out for friggin' years. It's just like this grueling
yeah,
endurance contest.
yeah. I know. Yeah, but I'm glad to be so close to the end. It's just a matter of reaching that finish line now. So I'm definitely ready for it to be over.
Yeah, awesome. Well, all the best. And where can people find out more about you? I know you've got some social media stuff, you've got some other areas.
Yeah, so I always forget what my tags are for Instagram.
It's probably not a bad thing.
Yeah, looking at them now. So it's gonna be underscore Nate Serrano underscore, and then you can find me on Twitter, I think, or X, whatever you want to call it. That's gonna be Nathan underscore Serrano. So pretty easy. Typically, you can just search Nathan Serrano and see my picture somewhere. But yeah, those are the main areas. I don't post all that often right now. I'll repost certain things, and certainly I'll make a post when this podcast comes out. But other than that, I'm fairly quiet these days on social media with the occasional research paper here and there. I'm probably more active on sharing research on X than I am on Instagram.
Very cool. Well, thank you so much for all your time. I really
Yeah,
appreciate it. Thank you.
yeah, thank you. Alrighty.
Thank you so much for listening to the podcast. Huge thank you to Nathan for coming on the podcast and talking all about his great research. We'll make sure to put a link to the study review that he did down below. And also, if you want his top 4 recommendations to someone who is untrained, what should they do? Check out the MikeTNelson.com/flex4. That's FLEX, the number 4, and you will get that sent to you exclusively. And that will put you on to the daily newsletter also, which we give you hopefully good information. At least I think it's good information, and try to make it entertaining at the same time. Plus, it's completely free. So you can go to MikeTNelson/flex4. Also, check out the Tecton ketone drink if you're interested in using ketones as a 4th macronutrient. I'm a scientific advisor to them and an ambassador, so full disclosure on that. But I do really enjoy them. I found them very useful, and they actually taste pretty darn good. So thank you so much for listening to the podcast. I really appreciate it. If you could link and share and all that good stuff, send it to a friend who may be interested. All that helps us out with the podcast, especially the subscriptions on Spotify, iTunes, wherever you're listening to it. Thank you so much. Really appreciate it. And we'll talk to all of you next week.
Well, they say all good things come to an end.
What's that got to do with this show?
This podcast is for informational purposes only. The podcast is not intended as a substitute for professional medical advice, diagnosis, or treatment. You should not use the information on the podcast for diagnosing or treating a health problem or disease or prescribing any medication or other treatment. Always seek the advice of your physician or other qualified health provider before taking any medication or nutritional supplement, and with any questions you may have regarding a medical condition. Never disregard professional medical advice or delay in seeking it because of something you have heard on this or any other podcast. Reliance on the podcast is solely at your own risk. Information provided on the podcast does not create a doctor-patient relationship between you and any of the health professionals affiliated with our podcast. Information and statements regarding dietary supplements are not intended to diagnose, treat, cure, or prevent any disease. Opinions of guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to therein. If you think you have a medical problem, consult a licensed physician.